Just like a previous problem, we have a loop with an inductor here. So this rod, initially it is at rest and then it is released. So it will start to fall. But it won't be a free fall because the induced EMF will cause an induced current, and due to induced current you will have a opposing force. So the acceleration will not be g, it will be less than that. But we need to find the x as a function of time, just like what we did before. So our approach is going to be same. We will see what is the induced EMF. From that we'll find what is the current, and from current we'll find what is the force BIL. So we'll see what is the net force on this rod, and from that we'll get what is the acceleration on this rod, and hopefully it will come proportional to the displacement x. So we'll get a equation of SHM. So let's begin. So this whole part is same as what we did in 4.65. So let the velocity is v at a general distance x. So the induced EMF is BVL, which will cause a current I to flow. So in this loop, BVL minus LdI by dt is equal to 0. V is dx by dt, which gives a relation between x and current, and that is I is equal to BL by L times x. Now if that current is flowing towards right, so you can see that restoring force will be upwards, and that will be BIL. I should not say restoring force, I should just say the force because of current will be BIL upwards. And mg is of course downwards. So I'm not saying restoring force because it's starting at the extreme. So in the previous problem, let me just show quickly. Here I use the term of restoring force because initially the rod was given the velocity v naught. So I had taken as x equal to 0. So if it has moved to a distance x, the restoring force will be in opposite direction, and that therefore I directly wrote BIL. But here the rod is starting at the extreme, so I should not say restoring force, I should just go for force. So force on this rod will be mg downwards, BIL upwards, and we have taken downward as positive, so let's say acceleration is also downwards. So now the force on the rod MA is equal to mg minus BIL. So you put the value of I here from here, and we get acceleration as minus of this thing, or minus this into x minus this. So acceleration is, so you can see acceleration is of the form of minus omega square x. So this is the force. So that's an equation of SHM, and we know this will be the mean position. Initially its velocity is 0, so that will be the extreme position. So if you plot it in the phase diagram, so if this represents x-axis, so this is x equal to 0, this will be a, and this will be 2a. Now this is the mean position, so that is same as amplitude. And when it starts from here, our standard equation is x equal to a 1 minus cos omega t. So at t is equal to 0, x is 0, and then as t becomes minus 1 eventually, x will become 2a. So that is our answer. Here you put the value of a as this amplitude, and we put the value of omega as this, root of this. All right.